Good evening. I'm here with Marvin, the drawing program that's included with the at the Pearson mastering site, and I'm going to show you how to draw some of these problems. I've assigned a practice homework assignment for you to practice before you do the quiz. You want to probably do the homework too. And I want to give you some extra practice with this because you're going to be asked to draw some structures, and these drawing programs they don't come with really good instructions, and rather than have you sit down and try to figure this thing out, I'm going to work through some of these things. I've already posted one video on this, but I'm going to do a few more on this one so you can see some of the things that are done. Just watch me doing it. These are problems that are on the practice homework assignment. All right, so I'm going to do those. So you've got some, if you can reproduce these on the homework assignment, you've got some free points there. Okay, first one I'm going to do is 1532. It says use condensed structural formulas to draw the balanced chemical equation for the hydrogenation of glycerol trilinoleniate, a fat containing glycerol and 3 linolenic acid molecules. All right. Condensed structural formulas. All right. Well, for one thing, when these are given you, these controls are actually going to be set up usually to actually give you a condensed structural formula. So what we need to do is, well, we got to get started here, and something's amiss, but let me standard view. That's right. There should be some boxes here. Let me stop this. There we go. I had to refresh this thing. All right, there's the glycerol trilinoleniate, fat containing, and so forth. Okay, they give you these boxes, and you can see there's 2 boxes separated by an arrow. Okay, the arrow is the sign, the reaction. So in this box is reactants, this box is the products. Okay, there's a couple ways we can do this. You can draw every individual atom. You got hydrogen, you got carbon. Or you could work with chains. I think working with chains is a little easier. If you know how many carbons are in the chain, it's easy. If you know however many atoms are in the chain, it's easy. Well, we know linolenic acid is a C18, 18 carbons. So let's draw an 18 carbon chain first. There we go. And I think we want to move that into the rectangle a little bit. Notice I clicked on that select button. And I'm just going to bring this down just a little bit. Yeah, you see, keep that in the box there. And I'm going to move this over a little bit this way so I have room to draw the glycerin, the oxygens of the glycerin. Okay, we've still selected this chain, but we're going to have to put some things on this chain. And it would be easier if we just draw the linolenic acid and then go ahead with do the copying, because we're going to need 3 copies of it. Trilinolenate, you see. Okay, so we've got that. Where are the double bonds in linolenic acid? You know it has 3. Well, we can start at the 9 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can put a double bond there. So let's do that. You click on this double bond thing. Okay, notice there's this opens up a menu and you've got these choices. So we want the double bond. To draw the double bond, all you do is hover over the bond you want to double and click. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be this one. You click on it. We could have gone from the other direction because we know this is an omega-3 fatty acid. So we just start 1, 2, 3. This is omega. So this is omega-1, omega-2, omega-3. So the double bond is going to be here. Well, now you know with the fatty acids, normally you have each double bond is separated. The two double bonds are going to be separated by a CH2 group. Okay, so you know that double bond, CH2, and then there. So those are our double bonds, carbon-carbon double bonds. Now we know this is CO2H, a carboxylic acid, so we need to get some oxygen functionalities on here. So we'll draw an oxygen there, And I'm going to draw this at kind of a strange angle. You'll see why. And then we need a double bond. So let's put the double bond here. Now, there's other orientations you could do this with. I've done this a few times, and I'm learning more and more tricks, and that's what you need to do. That's why you do problems. You learn various tricks of solving problems. But now we've got linolenic acid here, and we need 3 of them. Okay, we need let's put this in here. You see what I mean? And I like to separate these things with you're going to notice that this is going to be a very cluttered situation when we put all this together. So I like to draw these carbons fairly far apart, and they actually do that in some of when you ask for the answer. We can grab the single bond. Notice now when I draw the single bonds, it automatically adjusts the hydrogens. And we're also going to need we're going to need an oxygen. Okay, I had to break this for a second. I was called away for a moment, but here we are. We've got the linolenic acid. We're going to have to copy this, and then we've got the glycerin carbon chain. Now, I could put oxygens, and let me just do this for right now. I'm not going to keep these here. Okay, I can put these here. You see, and I could copy these things, and this is actually the chemical equation for the hydrogenation. We're actually going to do a hydrolysis here, but there's no point in having this here at this point because we're going to draw the triacyl glycerol. I'm used to calling them triglycerides, but that's the old days. Okay, but let's get rid of this. We're not going to. We could draw that. We don't have to because we're going to have. This oxygen is going to end up, well, actually the oxygen from here, that oxygen would actually be connected there. So strictly speaking, I probably should have drawn it this way and just not put this one in the first place. But this is, you know what? I'm going to do it right. So hang on here. I'm going to zap something here. Okay, I figured it's better to. It's probably a better idea that I actually work from the way this thing would be put together in the first place by chemical reaction. Okay, so we don't have oleic acid here, but you're going to see why this carbon is going to get attached over here. You'll see what happens. I'm going to copy this thing. Line these up reasonably well. I'm going to just going to only try this one more time. This didn't take the double bonds. There they are. It's just easier to do this way instead of drawing every one of them. Okay, now you see this is probably not as pretty as it could be, but we'll work with this. Okay, so we have this. Let's take this whole thing. As you see, we've got to get these carbon atoms attached to these oxygen atoms. So I'm just going to move this thing over a little bit. Okay, that's okay there. And we could finish this up pretty easily by just hitting single bond because we need this oxygen bonded to this carbon. So if we just grab this like that, you see, now we're done. Actually, now we're done with that. All right. And we need the hydrogenation reaction. So let's just copy this whole thing. No, I'm gonna actually do the thing stepwise. See what I just did? I clicked on here, the straight arrow and reaction. Okay, now we need 9 molecules of hydrogen. So this is easy. Look at this. 1, 2, 3, 4, 5, 6, 7, 8, and 9. You've got 9 molecules because you've got 3 here, 3 here, 3 here, double bonds. So those are your reactants. Now you need your products. Well, your product is simply going to be the hydrogenated version of this thing, which is glyceryl tristearate. So we copy this whole big thing. Control C. Now we hit Control V and maneuver this thing into here. Now, how are we going to get single bonds on here? Well, simple. You see, we go to this bond thing here, this bond menu. Click on single, and every place where we need a single bond. Remember, we're hydrogenating the double bonds. You click, and you're going to do it 9 times. And you should be done. If we've counted up everything correctly and we've attached everything correctly, we should have it done. So let's click submit and see what we get. Says it's correct. Now, we could have done it a number of different ways. We could have done this. I'm just going to do a couple of these just to show you how. You could draw you could go like 1, you could actually draw individual atoms, 1, 2, 3, and then, attach them, well, 1, 2, 3, 4, and so on up to 18 and so forth. But you could do it that way. There's a few different ways you could play around with this thing and get these things to work. I'm just learning this myself. In fact, you're always learning drawing programs. They have they have a lot of functionality in them, but you have to find them. You have to stumble on them a lot of times. But anyway, that's 1532. We're going to go to another one now. This one asks you to use line angle formulas to draw the balanced chemical equation for the hydrolysis of glyceryl trioleate. Now, that's going to be a little bit different. It's actually going to be, well, actually it's going to be similar to the hydrogenation one, but we're going to take the glyceryl trioleate that we just made from hydrogenation. How about that? And then we're going to hydrolyze it. And I'm going to show you one way you can draw cis double bonds. So let's get to the actually trioleate. That was trilinolenate, wasn't it? So it wasn't. There's the tristearate is what we made. So no, that scratch what I said. But anyway, trioleate. We need glyceryl trioleate. So we need 3 oleic acids. So let's draw them. C18. Well, oleic acid has you notice we didn't put the cis and trans double bonds in the other one, but I'm going to show you how you can put together cis double bond, because these are all double bond, the trans double bonds, if we just put the double bonds in them now. So we're going to stop that, And oleic acid, think about the structure of the molecule. Oleic acid has its double bond starting at carbon 9. So let's get to carbon 9. All right. And I'll show you another little function of this thing. Well, I'll show that actually. Let me draw the molecule first. And take, this will be carbon 10. This will be carbon 10, and there's going to be another 8 carbons. This is going to be carbon 9 and 10 over here. But I'm going to draw another 8 carbon chain, or draw an 8 carbon chain. 2, 4, 6, 7, 8. Okay. And I'm going to move this. I'm going to copy this. Remember this copy thing. Move it over here. Is that close enough? I move it a little closer. Remember, the main reason I'm doing this is so you can see how to work with some of these functions. Okay, that'll work fine. Well, now let's take a double bond. Hover here, move it to there, and there's your double bond. So that's how you do a cis double bond, or one way of doing it. I'm sure there's others. Okay, so we've got our oleic acid carbon chain. Now we need our oleic acid. This is acid hydrolysis of glycerol trioleate. Well, we're going to need oleic acid down here. So let's draw oleic acid. And remember, to draw any double bond, you go to this menu here, you click on that. And so now we have oleic acid. You know, I could make it look pretty. We could make it look pretty and have the double bonds all oriented the way they should be, but we don't have a lot of space here. So we have that. Okay. So now let's copy this. Copy that. Now Control V. That's not what we wanted to do. Hang on. There. Okay, now try copying that. Copy, Control C, Control V to copy. And let's just move these things down here. 3 of them. So there's our products. All right. Because we need the acid hydrolysis. Okay, now we're also going to need a couple more of these oleic acid molecules here. So let's put them down. Let's put them up here. Now we got to make our glycerol trioleate. Well, you've seen this before. Let's do this. Take these, line these up this way, and let's go ahead and put bonds between them. No, let's line angle. And we just drag these things, and there's our glycerol trioleate. We got one more thing we got to do. We have to make it a chemical reaction. So let's put the plus there. And what do we need? We need 3 water molecules because we've got to hydrolyze 3 carboxyl. We need 3 to hydrolyze 3 ester bonds. So we hit on oxygen, and here's a beautiful thing about this kind of software. It's geared towards organic chemistry. So if you hit an oxygen, you put an oxygen, it gives you water. It fills in the extra valences with water. That should be it. We should have it. That's all there is. That's the equation for the acid catalyzed hydrolysis. But it tells us we're wrong. What happened? Glycerol triolate is created from glycerol, a 3-carbon chain with 3 hydroxyl groups and oleic acid. Aha! We left something out. We left out the glycerin. So here's what we can do. We can fix this. Let's take this whole thing and move it over here and draw our glycerin molecule here. Get our oxygens. And I guess we could put the plus here for the indicate the reaction. Now let's try it. Still incorrect. Okay, well, now some of these mistakes are instructive here, because this thing is going to give you a hint, and it's going to tell you, if you read the hint, you read it closely, you might pick up what you did wrong. All right, so it says glycerol trioleate is created from glycerol, a 3-carbon chain with 3 hydroxyl groups. We know that. And oleic acid. Oleic acid is an 18-carbon chain, including the carbonyl carbon, with 1 double bond between carbons 9 and 10. Make sure that the starting material is the correct structure. Okay, let's look. Let's count this stuff up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9, 10. The carbons 9 and 10. We're correct there. 11, 12, 13, 14, 15, 16, 17. We're a carbon short. Well, how do we fix that? Simple enough. Grab our carbon. And of course, our angles aren't going to be quite as pretty as they should be. And why don't we, before we go on, let's take a look at our final materials, because if these were 1 carbon short, then this is probably 2. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We left those out. Okay. So we can do this, and this. Now, this should be right now. Let's see what we get. Okay, now it's correct. Okay, the lesson to be learned here is, first of all, pay attention to what you're doing, because I obviously overlooked. I thought I had 18 carbons in the chain, and I obviously did not. And these things are hard to keep track. I mean, you look at this chain here, and that's a lot of carbons, right? Okay. I click on submit, and I get something wrong. And oh my God, what am I going to do? I was careful about this. I did all these things carefully. I saw this, I counted everything, but now they say it's wrong. Okay, well, rather than panic, you go in and look and see, well, what's there? And they said this is a reaction between, you've got 3. They mentioned glycerol at one point. Now you look at the products. Oh, there was no glycerol there. How about that? Okay, well, you fix it. You put the glycerol in, which I did. Remember that? We put the glycerol in. And then, okay, I got it. It's done. Click on submit, and it's wrong again. And then they give you, check the structure of the oleic acid. what do you do to check the structure of the oleic acid? You know it's 18 carbons. So you check to see if you've got 18 carbons. I didn't have 18 carbons. So you put 18 carbons in and fix both the starting material and the product. You check the double bond, make sure it's in the right place. It was in the right place. So everything looked okay. So you have to be careful about these things. These are multi-step. These are multi-step problems. They're multi-step drawings. All right. So we got that. We got that right. We finally got to it. So we go to the next one. Okay, here we have, this is, problem is this, what number was this? The split personality of glycerophospholipids. This is tutorial, yeah. This one of the reasons I assigned some of these was not only to give you practice in identifying these things and reasoning through some of why these things are what they are and how they work, but to get you to see some of these functions on this drawing program. That's the main, that is the reason that I'm doing this video. Okay, because these are not necessarily intuitive, and this particular one is a little bit odd because the instructions it gives you don't really work. Okay. Here's your let's read this thing here. Glycerophospholipids are a class of lipids whose structures are composed of two very different regions. One part of the molecule is polar, the other part is nonpolar. Glycerophospholipids contain a glycerol molecule bonded to two fatty acid molecules, and as well as a phosphate group bonded to an amino alcohol. A lot of stuff there. You figure one. Okay, this thing here. There are three different amino acids that can be part of a glycerophospholipid: choline, serine, or ethanolamine. Now, let's look at this structure here. You see, here you have the fatty, well, here's your glycerol there, and then here's one of your fatty acids, and here's another one of your fatty acids. Okay, so then here's your phosphate and your amino alcohol, which happens to be ethanolamine. If you remember, there's serine as an amino acid, which next week we're going to be talking about amino acids. Choline would be, these would be methyl groups here, these three places. All right. Well, what they ask you is to select the hydrophobic regions of the regions of the glycerophospholipid shown. And they give you in bold these instructions. Identify the appropriate group of atoms by selecting each atom individually on the canvas and assigning them a map number of 1 until all atoms are mapped. To do this, right-click on an atom and choose Atom Properties. Now, if you have a Mac user, if you have a Mac, I can't help you, but you might be able to. That might work. What I end up doing might work with a Mac. Something what I'm doing might work with a Mac. I don't know. But then clear the check mark to enable the map field before entering a value. Well, then clear the check mark to enter the map field before entering a value. Well, right-click on an atom and choose atom. Let's right-click on an atom and choose Atom Properties. Right-click on an atom and choose Atom Properties. We could see it doesn't really. It says Atom Prop. Then clear the check mark to enable map before entering a value. Well, there's no check mark here, but there is this lock thing that opens it. So then you enter a value. They use the map number of 1. Okay, and there you go. And then what you would do is you take all of these things and assign them 1. But there's an easy way you can do this. You can select all of these. Notice I have the selection rectangle on here, so let's select them all. Now map properties, atom properties. There's map. This is not, they said a check mark. Well, this is not a check mark. So when I first did this, I'm looking, I'm racking my brains trying to figure out what's going on. Well, then I found this map field, and you click on that. Okay, now you're good. Now you hit 1, and there you go. You're all done. And that's going to be your hydrophobic region, right? Though the hydrophobic region is the hydrocarbon region. So we have that, and we click on Submit. And it's taking its time. And it's correct. We have it. Now, we have the amino alcohols, part of the glycerophospholipid and so forth. I'm going to let you work that. I already told you what this thing is. I already told you what it is, the carbon skeleton, the nitrogen, and the oxygen. And that, you should know that. So I'm mostly here worried about doing these drawings. All right. I'm going to stop here. I've been talking a little over half an hour, but I think I've given you some good information on how to do drawings using these programs. You can see that this drawing program and just doing the drawings in general, even if you're very, very good at it, requires care, requires concentration, requires a knowledge of the structures that you're trying to draw, and a knowledge of the different methods of drawing the structures. So with these, you should be in better chance now. You should be in better shape now to handle drawing programs that you're going to encounter, or drawing problems that you're going to encounter in doing these structures. So that's going to be the end of this video. Good luck.